Imagine a world where the sun dominates the sky with overwhelming force, where heat is so extreme that even metal would melt, only to plunge into a freezing darkness hours later, cold enough to shatter anything solid. This is Mercury, the closest planet to the sun, yet one of the most mysterious in our solar system. It has no thick atmosphere to hide its secrets, no moons to draw attention. It doesn't glow like Venus or boast massive storms like Jupiter. Mercury is the quiet planet, the loner, the forgotten one, and that's exactly what makes it so intriguing. How can such a small world with such a strange orbit tell us so much about the birth of our solar system? Why is its rotation so slow? And why does one side face the sun for what feels like an eternity? Today, we'll journey through ancient craters, strange magnetic fields, and insane temperature swings to explore Mercury, a planet that feels like it was forged in a cosmic nightmare. And as you'll see, behind its silence lies a universe of untold stories waiting to be uncovered. To understand why Mercury is such an extreme, solitary, and peculiar world, we need to travel back in time. Not thousands or millions, but billions of years, to the earliest moments of our solar system. Picture a massive disk of dust and gas spinning violently around a newborn star. The Sun. It was a chaotic battlefield, where rocks collided, fused, and gave birth to the planets. And in that cosmic war zone, Mercury was born. But from the very beginning, something about it was different. While planets like Earth and Venus were forming in more temperate zones, far from the sun's fury, Mercury emerged dangerously close. The heat in that region was so intense that many light elements were simply vaporized. That gives us an important clue. Mercury formed in a hostile environment where only the heaviest materials, like iron and nickel, could survive. The result? A planet with a gigantic metallic core making up about 85% of its radius. For comparison, Earth's core takes up only 55% of its radius. Mercury is nearly a floating core, wrapped in an incredibly thin crust. But how did this happen? One of the most accepted theories is the giant impact hypothesis. It suggests that Mercury may have started out as a much larger planet, possibly twice its current size. But at some point, a Mars-sized object slammed into it, violently stripping away much of its crust and mantle, leaving behind the dense core we see today. That event may have transformed an ordinary rocky world into something truly extraordinary. There are other possibilities, too. Some scientists believe that Mercury's closeness to the sun prevented it from ever collecting lighter elements during formation. The intense solar wind of that era could have swept those volatiles away, leaving only dense, heavy materials. In this view, Mercury wasn't stripped. It was born exotic, dense, small, and tough, and the anomalies don't end there. Mercury's orbit is extremely eccentric, far more oval-shaped than the other inner planets. It swings dangerously, close to the sun, and then flings outward in dramatic fashion. This could be the result of gravitational interactions with the larger planets, especially Jupiter. The gas giant's powerful gravity may have distorted Mercury's original path, forever altering its trajectory. Mercury also rotates in a strange way. For every 2 orbits it completes around the sun, it only spins 3 times on its axis. This is known as a 3.2 resonance, a rare phenomenon in our solar system. It's likely caused by a mix of its elongated orbit and intense tidal forces from the sun, yet another consequence of its brutal proximity to our star. Every feature of Mercury is a clue, a fragment of an ancient story we're still trying to piece together. It is the survivor of a cosmic war, a planet forged in fire, scarred by impacts, shaped by extremes, and left behind as a metallic enigma at the heart of the solar system. If we want to understand how worlds form, evolve, and survive chaos, and we must look at Mercury, because it holds answers no other planet does. Imagine stepping onto a world where the ground is as dark as charcoal, scarred by billions of years of impacts, cracked by brutal heat, and frozen by absolute cold, all within a single day-night cycle. This is Mercury's surface, an extreme, ancient and violent space desert. Mercury is covered in impact craters much like the Moon, but even more numerous and densely packed. These scars tell a story. Mercury is a planet that has barely changed in billions of years. Its crust hasn't undergone recycling like Earth's. There are no tectonic plates, no water erosion, no weather. What hits Mercury stays on Mercury. 1. Of the largest known features is the Caloris Basin, a colossal impact likely dating back around 3.8 billion years. This crater spans over 1,500 kilometers across, large enough to swallow a good portion of Europe. The impact was so powerful that it caused ripples on the opposite side of the planet. Literally, Mercury felt the shockwave from pole to pole, but craters aren't the only stunning features. Despite its inert appearance, Mercury hosts giant cliffs, immense fault scarps that stretch hundreds of kilometers and rise up to 3 kilometers high. These towering formations are signs that the planet shrunk. Yes, Mercury is literally wrinkled. This happened when its metallic core cooled and contracted, folding the crust like the skin of a shriveled apple. And what about the soil? It's composed of ancient volcanic rock, ejected when the planet was still geologically active. There are no active volcanoes today, but the marks remain. Dark seas of solidified lava and smooth plains spreading between the craters. Now for the most mind-blowing part, the temperature. During the day, under the relentless sunlight, the ice surface can reach 430 degrees, 800 degrees, hot enough to melt lead. But at night, with no atmosphere to hold the heat, temperatures plummet to 180 degrees, 290 degrees. This makes Mercury the planet with the most extreme surface temperature swings in the entire solar system. And despite all that thermal violence, Mercury has ice. Yes, ice. At its poles, inside deep craters that never see sunlight, there are deposits of water ice preserved for billions of years. They've been detected by radar, and their origin is still debated, perhaps delivered by comets, or maybe released from deep within the planet. Mercury is a world that is both scorched and frozen, static yet collapsing, and covered in fossil memories of a time when the solar system was pure chaos. When we think of an atmosphere, we imagine clouds, wind, maybe even rain. On Mercury, none of that exists. The closest planet to the Sun is virtually devoid of a true atmosphere. Instead, it has an exosphere, an ultra-thin layer of scattered atoms, so rarefied it can barely be called a gas. This exosphere can't trap heat, and it offers no protection from radiation. It's made of sodium, potassium, oxygen, and hydrogen atoms, constantly blasted off the surface by solar wind, micrometeorites, and intense radiation from the Sun. In other words, Mercury is in a state of constant bombardment and slow erosion. But here's what truly baffles scientists. Despite its small size and lack of a thick atmosphere, Mercury has an active magnetic field, something Mars, a much larger planet, lost billions of years ago. This magnetic field is about 100 times weaker than Earth's, yet it's still very real. The most accepted explanation is that Mercury's enormous core, which makes up most of its volume, is still partially molten, creating enough internal motion to sustain a magnetic dynamo. And here's a fascinating twist. Mercury's magnetic field is asymmetrical. Unlike Earth's, it isn't centered. The magnetic north is stronger than the south and is shifted toward the northern hemisphere. This creates a strange, lopsided magnetosphere, one that interacts with the solar wind in violent, unpredictable ways. These interactions lead to magnetic explosions, reconnection events that hurl accelerated solar particles straight into Mercury's surface, producing auroras, but not like ours. On Mercury, auroras are invisible to the naked eye. They happen in X-rays and ultraviolet, signaling a constant war between the planet and its star. It's as if Mercury stands naked before an angry Sun, shielded only by a thin magnetic veil, fragile, distorted, but still fighting back. Imagine a world where time seems frozen, where the surface has remained almost untouched for billions of years. This is Mercury. Its crust is a fossilized record of the primordial chaos of the solar system, a place where colossal craters, deep valleys, and towering cliffs tell the story of a planet shaped by impacts, extreme heat, and violent internal forces. The first thing that stands out when observing Mercury up close is the staggering number of craters. Like the Moon, Mercury has virtually no atmosphere to shield it from meteoroids, so its surface has become a cosmic battlefield. The craters range from tiny pits to giants like the Caloris Basin, over 1,500 kilometers across, one of the largest impact basins in the solar system. The collision that formed it was so intense that it created concentric rings and cracks on the opposite side of the planet. But Mercury isn't just a graveyard of impacts. It also features massive geological faults, known as lobat scarps, stretching hundreds of kilometers and rising up to 3 kilometers high. These formed as the planet's core cooled and contracted, causing the crust to shrink and wrinkle like a dried fruit. This shows that Mercury is still in some ways geologically active, or at least not entirely dead. Another fascinating detail is the presence of smooth highlands and vast lava plains, indicating an intense volcanic past. Unlike Earth, Mercury has no tectonic plates, but its surface was shaped by enormous lava flows that filled ancient craters and created more level regions, like the intercrater plains. And then, there are the strange, bright deposits found in younger craters. They reflect more sunlight than expected, and scientists believe they may contain volatile compounds or even water ice preserved in permanent shadow, where sunlight never reaches, even this close to the sun. It's a striking paradox. Ice on, the hottest planet in the solar system. Mercury's temperature is an extreme roller coaster. In the daytime, it can soar above 430 degrees, 800 degrees, hot enough to melt lead. At night, without an atmosphere to trap the heat, it plummets to 180 degrees, 200 degrees. This brutal temperature swing gradually weathers the surface, cracking and breaking rocks over time. Every scar, every fracture, every hill on Mercury is a time capsule, preserved for ages. A portrait of a planet that survived the violent birth of the solar system, bearing on its scorched face the marks of billions of years of history, and still hiding secrets we're only beginning to uncover. Talking about climate on Mercury is, at the very least, provocative. After all, this is a planet that virtually has no atmosphere. But it's exactly this absence that makes its environment so extreme, hostile, and fascinating. Mercury doesn't have a thick atmosphere like Earth. Instead, it has an exosphere, an ultra-thin layer of atoms released from its surface by constant micrometeorite impacts and solar wind bombardment. It's so tenuous that it can't trap heat or generate weather systems as we know them. The result? Mercury experiences the most dramatic temperature swings in the entire solar system. By day, with the sun blazing directly on its surface, temperatures can soar beyond 800 degrees, 430 degrees Celsius. There are no clouds, no air to diffuse sunlight. The sky stays pitch black even under full daylight. But during the long, airless night, temperatures plummet to 290 degrees, 180 degrees. In mere hours, Mercury swings from oven to cosmic freezer. This brutal contrast creates unique effects. Rocks expand violently in the scorching heat and contract abruptly in the deep cold, cracking, splintering, and breaking apart. This process, known as thermal weathering, slowly reshapes Mercury's barren landscape over time. And while the sun appears enormous in Mercury's sky, over 2.5 times larger than it does from Earth, its heat doesn't spread evenly. Because of the planet's slow rotation and elliptical orbit, some areas accumulate heat more intensely, while others remain cold for long stretches. This creates thermal zones that even influence the local geology. Now, the most intriguing part, in some craters near Mercury's poles, where sunlight never reaches, scientists have detected water ice. That's right, ice, on Mercury. It likely arrived via comets or asteroids and has remained preserved in the permanent shadows. It's a surprising clue that even the most hostile corners of the solar system can hide ingredients critical to life. Mercury's climate isn't made of winds, clouds, or storms. It's made of brutal radiation, absolute silence, and thermal contrasts that defy logic. A world where the heat of hell and the chill of the void coexist with no gentle in-between. And even in that chaos lie valuable clues to the history of our solar system. So now you've seen it. Mercury isn't just a dead rock baking in the sun. It's a cosmic paradox. A planet that roasts by day and freezes by night. A world with no air, no storms, but holding secrets like ancient scars, collapsing cliffs, and frozen water in eternal shadow. And yet, it's right there, the closest planet to the sun, the one we almost always ignore. If Mercury blew your mind, imagine what else is waiting out there. Subscribe to Nebula Verse now, because this is just the beginning.